Okay. Kia ora, everyone. Good afternoon. Thanks for the introduction. Today I'm going to present some of the insights and the studies I conducted as part of my visiting semester in two of the national and provincial agency managing roads in Italy, lately involved in the road infrastructure management for the Italian context. So basically it was related to this important topic that we face in everyday life, and even most recently it's even more evident, where in Europe and not only we have aging infrastructure, road infrastructure, in which that are positioned in a constantly challenging reality. We have issues related to the maintenance with cracked pavements or parts of buildings or other road asset. We live in a world with natural hazard threatening network continuity of roads, as well as we have, of course, climate change. Here it's more evident than in other parts of the world. Also in Italy we have a lot of issues related to climate change that leads to a lot of extreme events affecting the operability and serviceability of the network. And then in the most extreme situation we also have structural failures related most of the time to poor management of the infrastructure. So most of the time, also medium and small size road asset manager have to deal with this very interdisciplinary and complex environment with a lot of issues, and often it has to do that with limited resources. So with the release of new norms, new guidelines related to the mapping of the situation of their assets, when I started talking also with the people affected by this issue in Italy, the first things that came to their mind was like, okay, how can I start to build something that can manage all of this stuff? Maybe we need a bigger Excel. It might be surprising, but yeah, there are still a lot of agencies in Italy that still deal with Excel. They have not explored other component of the outside the pure tabular data. So the idea behind this work is to explore what's there. I don't want to reinvent the wheel or invent something new, but try to map what is documented in literature with case studies from Google Scholar, indexing Google Scholar and Scopus, filtered for application that involve the adoption of geo and open source approaches for road asset management, and also for the facilities and operation connected to this road. And in particular, not only involving open source tools and also analysis of the standards, adoption, but also involving collaboration of the academia with the public administration directly. So after the first filtering, another work required understanding if the case studies work directly, closely with the public administration, because it's an issue in which a lot of people are involved. There is an issue of communication, interdisciplinarity, and also all the tools used need to be operational in an effective way. So in order to make sense of the fragmented literature around the topic that most of the time involve proprietary software, well-established proprietary software that most of the time are black boxes, I organized the findings of my research, my filtering, into a 4-layer frameworks based on the Wu and Musavi proposal for the infrastructure of a digital twin, identified as the foundation for a proper digital twin, with the data layer covering the data sources information, an analysis on the approaches for data collection and sharing, as well as the model layer in which the data are then structured in models, with also the adoption of specific standards in the industry and the field. And then the service layer, understanding what's outside there has been tested already in some case studies about analysis, safety, assessment of road networks, and then application layer mostly related to how all the insights are also communicated with visualization and interactive approaches to the decision maker involved in the process, that most of the time are not IT people or geomatic people. So this is the structure of the presentation, covering these 4 sections that then lead to the discussion and conclusion with some of the main insights related to what I found in the 4 areas, and also some challenges and future direction that also as a researcher and people involved also in the community connected to the decision maker, we can do in order to move forward toward a better management of the road assets. So let's start from the data layer. Before even we go on site, we collect field, geomaticians know most of the time we go there, we face different weather conditions and so on. We can already, starting from the literature, so it's well established, the adoption of open data that are easily downloadable from different resources, mainly OpenStreetMap. Because something I noticed also collaborating with these agencies is that even if Italy is famous for its long tradition in geomatics, surveying, photogrammetry, there is still a big issue in seeing the operational of these things and also knowing where is a bridge sometimes or any other assets, it's a challenge. They don't have the coordinates of the asset themselves. They rely on their own local coordinates, linear coordinates, it's a big issue. And so for a lot of studies lately, the OpenStreetMap data, based also on a very active community in Italy, became an important starting point for understanding already how the assets are distributed on field. Then, of course, the Copernicus program with the open release of their data allowed to understand the territorial context, understand also how the terrain is modeled, if there are issues related to flood modeling, as well as also understand the land use, the land cover, and what's around the single structure or infrastructure. And then, more recently, there is a big adoption of data related to continuous monitoring using the European Ground Motion Service, and so mostly SAR data to understand also deformation and have a better frequency in their observation of what is happening. But sometimes the data are incomplete, inaccurate, not enough detailed for the application that people is interested in doing, and so there's been also a focus now well established with a lot of good state-of-the-art approach in the data collection that usually involve a lot of open source solutions and their combinations, starting from mobile GIS and apps. Before we were talking about Kobo Toolbox, I found the literature case studies adopting ODK, for example, so, especially for its easy-to-access interface that is mostly form-centric, so allows also people not familiar with Geomatics map to add their observation, but also the more familiar to us in FOSS4G, QField, or emerging maps that directly connect to QGIS or other software well-established. However, most of the time, the simple vector data collection on field or simple tabular collection is not enough, and so the old-style field surveyor are playing the game of the 3D field surveys with the collection of high-quality images, high-resolution 3D digital outputs processed from these images to create a digital surface model, orthophotos, and so on that are essential for following analysis. And regarding the open source approach in this case, there's not a lot. Unfortunately, a lot of studies still rely heavily on proprietary software for photogrammetry especially, and management of drone data. And so I identified some of the approach, but they are still not very well integrated in a full open source environment or workflow. Then, of course, it comes to where the data are archived. There are two main approaches. I would say the most established one is the relational database approach, good for heavy load, and also with PostGIS allows easily to handle spatial queries and geometry storage. A lot of literature relies heavily on this combination, with few exceptions with MySQL and SpatialLite. But most recently, especially the community of structural engineers, most involved in BIM studies also, relies on graph database. And so there is this big trends in the community of road asset manager in exploring together with agencies advanced network analysis based on graph database approaches. So, of course, we arrive also to the part of the data sharing, because we have also to communicate in some way the data in order to build our entire infrastructure. And, of course, in this case, we need having geodata, a GIS server. In this case, again, in literature of open source studies, I found a lot of cases with GeoServer, well connected with other kind of approach, also behind GeoNode, that allows also the compliance with OSGeo standards for serving spatial data, and also allowed an efficient data management from a backend database. So, moving to the model layer, this is where we define how our data are modeled, and also which standards are involved in the game. This is the tricky part, and that's the one that usually create a lot of argument within different people at conferences discussing about management issue, because the standards, of course, for the design and construction is IFC with the ISO reference that is, of course, optimized for this kind of application related to parametric geometry. There is then the standard, of course, of CTGML, more for optimized for analysis and simulation, and especially for city scale, is heavily adopted in the case of digital twin, urban digital twin lately, but it's still a bit challenging to integrate and make this standard communicate in a single BIM GIS infrastructure, for example. And so a lot of researchers explored this communication through the land infra GML standards, specifically for civil engineering, but it's mostly focused on linear features. So again, the geometry and the reference component still collapse and clashes with all the different standards. So this is still a big open question in the field. So we have the BIM domain that is playing a big part in the game with local coordinates and parametric geometry, highly detailed at the level of single structure and asset of the road. And then on the other side, we have the GIS domain with global coordinates, urban territorial scale. And yeah, we have the conflict in the mismatch, data loss that create a mismatch and data loss in the terminology. But also we have some trends, again, coming mostly from the structural engineering field, that try to link these two levels of details, especially with graph approach, with a graph approach, knowledge graph approach, in order to connect the BIM with a larger environment and optimize network level analysis for the roads. Now that we have the data and the model, we can generate the value also connected to the structure for the management of the data. And so we can go to the service layer. And in this case, I managed to identify three main topics, three main applications for studies and case studies. And probably this is the most vibrant part of the whole infrastructure in terms of research with the recent advancement in computer vision, AI. We have first safety assessment related to the identification of failure damages on specific part of the infrastructure. We have simulation, that is the one with probably a longer experience and more established, with also R packages or other statistic related also tools. And then we have the monitoring that is directly connected also, for example, to the SAR data that I mentioned before in the first part of the presentation. So I try to make a small focus on safety assessment, so the first part, and then the simulation analysis. The safety assessment at the moment heavily rely on a lot of open source libraries. Some of these are YOLO, SAM, probably the most used. So image-based approaches that we are seeing that are taking over basically computer vision. We have for sure object detection, in which we identify on satellite imagery, so different scale, satellite imagery or drones imagery that we have for specific survey of assets on the infrastructure. We identify some specific components, so we can isolate sign, traffic signs, safety barriers, in order to then start a pipeline of advanced processing to understand if those elements identified in the object detection are affected by specific failure or damages that need the attention of the decision maker. And then, indeed, these are classified. Mostly we have YOLO is probably the most famous one. Then we have also the image segmentation, a lot of application in this field, highlighting that highlights and quantify also the presence and extension of defects or damages on surface and or asset of the street. In this field, especially also on, at the level of the whole network, there are a lot of application also that doesn't only involve the adoption of open source libraries in the computer vision field, but also georeference the results of these studies. So it's something that most of the time feed a GIS system. It doesn't remain like a simple experimental application. So it's very interesting in this field. And then in the end, we have a machine learning application for mostly point clouds. For identifying cracks and deformation directly on point clouds with some clustering approaches and other popular libraries. But still also in this case, most of the time, the case studies remain some very limited experimental case that are not then inserted in a larger framework of management. Moving to the simulation, here we have mostly they are focused on the execution of planning and optimization of tasks along the highways that support indeed the high-level decision-making of the public agencies usually involved in the management. And in this way, it is optimized also the allocation of resources along the highway. So, of course, the first application that comes to mind is the one that is found also in literature, in the analyzed literature, that is network analysis, mostly based on popular packages like OSM and XNPG routing. That allows indeed analysis on short path and also application for optimized path of intervention along the street, also for specific emergency when maybe part of the network is interrupted for some reason. And then we have trajectory analysis with a lot of application of moving pandas that has quite good community also behind, that allows to identify also patterns in the movement along the highways, understanding also which are maybe the hotspot at the scale of the network that maybe require more interest in case of failure or other issue in serviceability. And then we have mobility simulation, more of a niche of a lot of specific simulation software that analyze traffic flow and capacities within usually the scale of a city. There's a lot of application in the city, at the city level, but it's more rare to see at the level of an entire region, of course, also because it requires a lot of data, or also at the level also a simple province, for example, in Italy. Moving to the last part, we have the application layer. In here, the literature has two main trends. We have this kind of application layers focused on visualization and interaction that mainly identify two modules that interact in different way. We have the GIS module for the territorial scale visualization, interaction, querying of feature with simplifying the or custom interface, and QGIS is largely adopted in this case. And also for the BIM module, proprietary software are still quite diffused, of course, probably more mature also, so under a certain perspective. There are applications that involve QGIS for the GIS module, and then something proprietary for the BIM visualization. But there are some cases in which models in Blender, for example, or with Blender BIM are linked to a specific feature inside the GIS, and so some kind of management in two distinct spaces. Moving to the web-based visualization instead, we have again GIS module with many applications of leads map, for example, for the visualization on a web page and management of the territorial scale, but also some more specific application for the 3D data module, not only BIM, for point clouds, extraction of measurement with PO3, cesium, And also a lot of adoption in XeoKit that at the moment has not a direct interaction with maybe cesium, feeding directly geospatial context, but it's highly used also for the visualization of IoT module and the connection to graph-based infrastructures. Move to the discussion and conclusion. We have still a big challenge on the integrated workflow. I try to map them. Most of them are, especially in the service layer, they still remain experimental approaches to specific problem or to the data feeding and update of what we have in our digital twin, or at least a prototype of digital twin. And so they address specific areas. It's very difficult to find something that has both maybe advanced analysis of images that are also georeferenced in their geospatial context. And this is still challenging and limited to people with high expertise. And so maybe it's not fully operational for people in the management of the transportation network. And so, yes, the seamless integration is still, let's say, a big utopia at the moment, with, and it's still a critical and underdeveloped challenge in the research. In the end, also, another thing that is often addressed is the issue with cross-platform compatibility issues, because even if some people manage to deal with the data layer, model data, and also visualization layer, they manage to integrate in some way these three components, still have issues when moving to different devices or interfaces, and so this is still a limitation, especially in interoperability. So the main point, what we can do as a researcher, as users, as a part of the community of the open source environment, not keeping our secret, basically. That's something, it's something wider that goes beyond the simple application of this field. Most of these application experimental studies are using open source tools, but do not share the code or publish the workflow in a detailed way. And so these hinder a lot, again, the reapplicability or reproducibility of some studies. And also, it's difficult in this way also to define an adequate system that handles the training of the people involved in the field directly, in order to make them self-sufficient also in the adoption of these more advanced technologies that are going at super fast, let's say, in the adoption. And so the goal is that the resources need to be shared and not to be exclusive, especially if they use open source that by definition should be inclusive. So to conclude, I really wanted to use this in New Zealand. We have a system that we need a system that is able to rule all these parts and is able to adopt model in a proper way, and also especially support the end user of this kind of application that most of the time have their own experimental approach, but then do not have a long-term plan for maintenance. Thank you for your attention. Sorry for the extra time.
Thank you, Federica. Do we have any question?
Yeah, thank you for your talk. I really enjoyed it. I'm interested in how sort of risk and natural hazards are included within these systems. I guess from my experience, I found that the asset data is quite good and that the attribute information is quite good, but there's a lack of understanding or integration of natural hazards like flooding or liquefaction within the asset management systems. Like, how have you found, what's the best approach, do you think, from your experience?
Okay, okay, stay here. From what I found in the literature, I see that there is at the scale of the network system for flooding event, there are some studies that are not entirely based still on technologies that are fully accessible. So I highlighted it because it's an issue. It's still an open question also, this thing. And for sure, I think with the European ground motion system, there's a lot of space for improvement in that field. And also in that case, with some satellite imagery analysis, we can have a lot of insights. But in that case, again, I found very specific case studies, and they were not inserted in a framework, having a more structured approach. There are a lot of studies, of course, in this field, but not involving maybe directly public administration or the people involved in that specific management. So they remain experimental approaches. So I try to narrow a little bit in order to find more direct operational approaches also. So I hope in the paper I will be more detailed. Yeah.
Any other questions? Well, then join me in thanking Federica for her talk.